Dear students, welcome back to my video lecture 4 on hydrogen and its compounds. So in the previous video we spoke about the chemical properties of dihydrogen. We have learnt the reaction of dihydrogen with halogens, nitrogen, oxygen, and then with reducing nature of dihydrogen, and then with metals, and also the reaction of hydrogen with organic compounds. Okay, well, I told you why hydrogen is less reactive and what has to be done if I have to use hydrogen for the various other reactions in the laboratory. Okay, isn't it? Now in this video we will talk about the uses of dihydrogen, and then we will solve the MCQs as I had promised in the previous class. Okay, now we will be talking about the uses of dihydrogen. Okay, again this is also important. See, so even though this is a small chapter, students, even though this is a small chapter, the questions for your CET and NEET examination may come from any concept. Okay, you cannot predict. It seems like this chapter is very easy and you can study and you can do it. But the questions, you cannot predict the question, where the questions comes from. The question might come from any corner of the chapter. So you should be well versed with all the concepts. That is why I am going in detail with all the concepts particular to what hydrogen. Okay, yes. Now what are the uses of dihydrogen? Okay, the first use, there are 6 to 7 uses. Please remember all the uses because there are chances that the questions might come from uses also. Okay, so what are the uses of dihydrogen? The first use, see, we know dihydrogen is used, it is used in the preparation of ammonia. In the preparation of what? Preparation of ammonia, isn't it? In the preparation of ammonia, is that correct? Okay, and what is so big deal with ammonia? We know ammonia is an excellent starting material for the preparation of various other fertilizers, isn't it? Various fertilizers. Okay, fertilizers. So if I have to, for example, potash, urea, DAP, etc., for those fertilizers, ammonia is the best starting material. Okay, and how did we get this ammonia? When nitrogen reacts with hydrogen. Okay, are you getting my point? This is one of the very important use of dihydrogen. It is used in the production of ammonia, and ammonia is an excellent starting material for the preparation of various fertilizers. Okay, and we know hydrogen. Yes, hydrogen is used in the preparation of HCl. Yes, preparation of HCl, again a very important use. It is used in the preparation of HCl. And we learnt how do you convert vegetable oil to vanaspati ghee? By hydrogenating it, isn't it? Correct. How do you convert a vegetable oil to vanaspati ghee? By hydrogenating the vegetable oil, isn't it? So only that means it is used in the reaction. It is used in the reaction with organic compounds, isn't it? It is used in the reaction with organic compounds. Yes, see, in one of the reaction I told you, hydrogen is produced in the form of Syn gas. A very important gas. What is Syn gas? Look at the use of Syn gas. Syn gas is nothing but a mixture of carbon monoxide and hydrogen. Using this mixture, I can prepare various other organic compounds, guys. Using the mixture of carbon monoxide and hydrogen, I can prepare many other organic compounds. For example, look here, when carbon monoxide reacts with 3 moles of hydrogen. When carbon monoxide reacts with 3 moles of hydrogen, it will form, what does it form? When carbon monoxide reacts with 2 moles of hydrogen, it will form methanol. Look at here, a very important organic compound. When carbon monoxide reacts with 2 moles of hydrogen, it forms methanol. When carbon monoxide reacts with 1 mole of hydrogen, it will form formaldehyde. Again a very important organic compound. So that means hydrogen in the form of Syn gas is a very important mixture for the preparation of various other organic compounds. Isn't it? Is that correct? Now what are the other uses of dihydrogen? Yes, excellent. Hydrogen is used hydrogen is used, okay, in welding, isn't correct? Hydrogen gas is used for welding purpose, okay. It is used for what? Welding purpose, okay. And very important, Rihanna, use that hydrogen gas, the combustion of hydrogen gas will produce enormous amount of energy. The combustion of hydrogen gas, just now I told you, okay, look here, hydrogen combines with oxygen, okay, to form what? Water. This is a very, this is an highly exothermic reaction and high amount of energy is released, okay. That is what I am telling you. The combustion of hydrogen will produce enormous amount of energy. That is why hydrogen gas is used as a rocket fuel. It is used as a rocket fuel. It is used as a rocket fuel. And lastly, hydrogen gas, okay, is used, okay, in the production of energy, in the energy production in fuel cells. See guys, we will talk about fuel cells. When we come to 12th standard in a chapter called as electrochemistry. In electrochemistry, we will study about fuel cells in detail. There we will come across this, okay, step. Hydrogen gas is used in the energy production in fuel cells. So these are all the various, okay, important uses of dihydrogen. Please note all these points. And now, okay, we will be going with MCQs related to what are the different topics that we have covered so far. We have covered hydrogen, position of hydrogen in the periodic table, isotopes of hydrogen, correct, the different methods of preparation of hydrogen, physical properties of dihydrogen, okay, then the different types of dihydrogen, chemical properties of dihydrogen, uses of dihydrogen. So on all these aspects we will solve the MCQs that is there in your MTG fingertips, okay, students. So I have this question. Okay, if you have understood the concepts and if you have watched all my videos, it is easy, you can go, okay, it is just yes or no question, that's it, okay. The question is like this, okay, in what respect electronic configuration of hydrogen and halogens are similar, okay. See, okay, so now we know with respect to electronic configuration, okay, I have what alkali metals, okay, and then I have halogens, and then I have hydrogen. What is the general electronic configuration of alkali metals? ENS1. And how about halogens? It is ENS2, NP5. They require one electron to complete their octet and attain noble gas configuration, isn't it? Okay, isn't it? Correct? Okay. Halogens require just one electron to complete their octet and attain noble gas configuration. Okay. How about hydrogen? Okay. The electronic configuration of hydrogen is also 1s1. It also requires one electron, okay, to attain the nearest noble gas configuration. Which is the nearest noble gas configuration? Helium. Okay. Correct? Yes. So hydrogen resembles alkali metals in its, okay, in their general outer electronic configuration. Just like halogens, hydrogen is just short of one electron to complete the octet and attain the nearest noble gas configuration. So in the question they are talking about similarity of hydrogen with halogens. So what might be the answer? Hydrogen and halogens have one electron in their outermost shell? No. Okay. Yes, halogens have 7 electrons in their outermost shell. Hydrogen has 1 electron in the outermost shell. Okay. Hydrogen and halogens have 1 electron less than the noble gas configuration. Yes, this is correct. No, halogens is short of 1 electron. Hydrogen is also short of 1 electron to attain the nearest noble gas configuration. I hope you have understood. So we shall go with the next question. Yes, next question. Okay. In which of the following properties hydrogen does not show similarity with alkali metals? Okay. Yes. In which of the following properties hydrogen does not show similarity with alkali metals? Okay. Now even look here, sodium, that is okay, all alkali metals will lose one electron and they form, okay, a unipositive ion. A hydrogen will also lose one electron and forms unipositive ion. This reaction shows that just like alkali metals, even hydrogen is electropositive in nature. Yeah, okay. So hydrogen resembles alkali metals in its electropositive character. That is correct. Just like alkali metals, even hydrogen is a reducing agent. That is correct. Okay. Yes, in its electronic configuration. Yeah, in its electronic configuration, yes, just now I told you, in terms of electronic configuration, alkali metals have outer electronic configuration of ns1. Hydrogen resembles alkali metals in its outer electronic configuration. The electronic configuration of 1s1, hydrogen is 1s1 and alkali metal is ns1. So hydrogen resembles alkali metals in electropositive character. It resembles alkali metals in reducing nature. It resembles alkali metals in electronic configuration, but alkali metals are monoatomic. Hydrogen is diatomic. That means hydrogen does not resemble alkali metals in this character. Okay, hydrogen exists as a diatomic molecule. Okay, alkali metals are monoatomic nature. That means hydrogen does not resemble, okay, alkali metals in its diatomic nature. Got it? Yes. Next question. Okay, which of the which of the following is not an isotope of hydrogen? Yes, just now we spoke. Okay, yeah, what is it? Okay, what are the different isotopes of hydrogen? Protium, deuterium, tritium. That means protium is an isotope, correct? Deuterium is an isotope. Okay, tritium is an isotope. Protium 1H1, deuterium 1H2, tritium 1H3. But what about ortho and para hydrogen? Yeah, in my previous video I told you ortho and para hydrogen are not isotopes. They are what? They are nuclear isomers. They are nuclear isomers, or else they are also called as nuclear spin isomers. Okay, they are not the isotopes. Okay, so what is the correct answer? It is option B, ortho and para hydrogen. Understood? Yes. Next question. Which of the following metals, okay, will react with sodium hydroxide and potassium hydroxide to liberate, okay, hydrogen gas? Which of the following metals, okay, will react with sodium hydroxide and potassium hydroxide to liberate hydrogen gas? See, I told you, okay, yes, have told you that metals, okay, when they react with mineral acids, okay, they liberate hydrogen gas. Okay, similarly, if metals react with what? Okay, bases, in this case also they liberate hydrogen gas. But there is a condition. Okay, for a metal to react with mineral acid and liberate hydrogen gas, there is a condition for a metal to react with base and liberate hydrogen gas. What is the condition for a metal to react with mineral acid and liberate hydrogen gas? Okay, yeah, it should be an highly reactive metal. Like that means I have told you this in the very beginning of my video. Okay, so electrode potential of this metal, okay, should be less than, okay, the electrode potential of hydrogen. Okay, if the electrode potential of the metal is less than the electrode potential of hydrogen, then only that metal can liberate hydrogen gas, okay, when put in what? Mineral acid. Okay, for example, zinc, okay, aluminium, iron, okay, all these they have what? Electrode potential less than that of iron. Hence these metals can liberate hydrogen gas from mineral acids. Then what is the condition here for a metal to react with a base to liberate hydrogen gas? For a metal to react with a base to liberate hydrogen gas, it should be amphoteric metal. It should be an amphoteric metal. So which are the amphoteric metals? It is, yeah, come on, zinc, okay, tin, aluminium and lead. Okay, zinc, tin, aluminium and lead. These are called as amphoteric metals. They react both with acids as well as bases. So such amphoteric metals, when they react with bases, they liberate hydrogen gas. So can we answer this question? Which of the following metals will react with sodium hydroxide and potassium hydroxide? Sodium hydroxide and potassium hydroxide are bases. Therefore, the metal should be amphoteric. Which are the amphoteric metal? Yes, zinc, tin and aluminium. Okay, this is the correct answer. Okay, isn't it? So next question. Yeah, which of the following metals, okay, does not liberate hydrogen from acids? Which of the following metals does not liberate hydrogen from acids? Yeah guys, I told you. Okay, for a metal, okay, to liberate hydrogen gas from acids, the electrode potential of the metal should be less than the electrode potential of hydrogen. What is the electrode potential of hydrogen? Okay, it is 0 volts. Okay, what is the electrode potential of iron? It is minus 1.36 volts. Somewhere it is not exact, it is somewhere minus 1.36. okay, what is the electrode potential of magnesium? What is the electrode potential of copper? It is plus 0.34 volts. Electrode potential of magnesium is minus 2 point something, and electrode potential of zinc is minus 0.76 volts. Okay, observe here, the electrode potential of iron is less than hydrogen, therefore hydrogen can liberate iron can liberate hydrogen from, okay, what, acids, isn't it? And also the electrode potential of magnesium, it is minus 2 point something. Okay, so electrode potential of magnesium is also less than that of hydrogen, hence even magnesium can liberate hydrogen gas from dilute acids. Okay, electrode potential of zinc minus 0.76 volts, it is less than the electrode potential of hydrogen, hence even zinc can liberate hydrogen from dilute acids. But look at the electrode potential of copper. Electrode potential of copper is plus 0.34 volts, it is more than that of hydrogen, therefore copper cannot liberate hydrogen gas from acids. Understood? Okay, for any metal to displace hydrogen gas from acid, the electrode potential of that metal should be less than the electrode potential of hydrogen. Okay, clear? Yes, next question. Yeah, the production of syn gas from sewage, sawdust, scrap wood, etc. is quite common these days. The production of syn gas from coal is called as, what is it called as? Okay, all the answers are available in my video lecture 1 and video lecture 2. The answers for all these questions are available in my video lecture 1 and video lecture 2. Okay, the production of syn gas from coal. How do you produce syn gas? When, okay, when steam is passed over red hot coke, it will give carbon monoxide and hydrogen. The mixture of carbon monoxide and hydrogen is called as syn gas. And what is this reaction called as? It is called as coal gasification. This reaction is called as what? Coal gasification. So what is the answer? It is option C. Got it? Yeah. Next question. Water gas, yeah, is mixed with steam and the mixture is passed over heated iron oxide in the presence of chromium oxide. The mixture when passed in water, okay, dissolves carbon dioxide and dihydrogen is left undissolved, is collected. This method of preparation of dihydrogen gas is known as, okay, what is it? Now look here, very simple guys, look here, okay, carbon monoxide. Just now we learnt coal gasification, isn't it? When steam is passed over red hot coke, okay, red hot coke, it will give a mixture of carbon monoxide and hydrogen. This is called as syn gas and the reaction is called as what? The reaction is called as coal gasification. In this reaction, the yield of hydrogen is quite less. The yield of hydrogen is very less. So what is that you're going to do is, again we'll pass this, okay, yes, syn gas, okay, over what? We'll pass it through, we'll pass this through, okay, again steam. What is that we're going to get? We will be getting carbon dioxide and hydrogen. We'll be getting carbon dioxide and hydrogen. Now this carbon dioxide is dissolved in water. The carbon dioxide is dissolved in water and hydrogen gas liberated will be collected. Hydrogen gas will be collected. Understood? Okay. This is called as water gas shift reaction. What is this reaction called as? Water gas shift reaction, and the process is called as Bosch process. Okay, the process is called as what? Bosch process. Hence the correct answer is option A. Okay, yes, next question. Okay, if a mole of hydrogen molecule is heated to a high temperature, then which of the following reaction takes place? Quite logic based, guys. Quite logic based. Okay, yes, I have told you, if hydrogen molecule is heated, okay, if hydrogen molecule is heated, okay, it will break to give hydrogen atoms, isn't it? It will break to give hydrogen atoms. But what should be the energy? What is the amount of energy that must be supplied to this hydrogen molecule so that it will break to give hydrogen, atomic hydrogen? Okay, it is in the order of 439 kilojoules per mole, isn't it? Okay, if I heat hydrogen molecule, okay, with a temperature wherein I am supplying 439 kilojoules per mole of energy, okay, then hydrogen molecule will break to give atomic hydrogen. Okay, atomic hydrogen is more reactive than what? Hydrogen molecule. Understood? So what is the correct answer for this? Yeah, the correct answer is option A. Option A, isn't it? Yeah. Okay. Yeah. Next question. Which property of hydrogen is shown in the following reaction? Which property of hydrogen is shown in the following reaction? Observe here. Okay, yeah, we discussed this. Look at, observe the reaction, very simple. Okay, Fe3O4 is reduced to iron, isn't it? Okay, yeah, and carbon monoxide. What is reduction here? What is reduction? Reduction is removal of oxygen or else addition of hydrogen, isn't it? So from now, what is it? Iron oxide, we have removed oxygen and okay, we have reduced iron oxide to iron. Okay, iron oxide is reduced to iron, hydrogen is oxidized to water. Iron oxide is reduced to iron, okay, hydrogen is oxidized to water. So what reaction is it? It's a reduction reaction. Here also, carbon monoxide is reduced to methanol. Carbon monoxide is reduced to methanol. Reduction is addition of hydrogen. To carbon monoxide, we have added hydrogen so that it gives methanol. Addition of hydrogen is also reduction. So this is a reduction reaction. This is also a reduction reaction. So which property are we talking about? We are talking about reducing character of dihydrogen. We are talking about what? Reducing character of dihydrogen. So what is the correct answer? The correct answer is option A. Got it? Yeah. Next question. Yeah. A metal M produces a gas N on reaction with alkalis like NaOH, KOH. Okay. I told you. Okay. Yes, I told you that if a metal is reacting with an alkali, okay, that means a base. What type of metal can react with a base? Amphoteric metal. Which are those amphoteric metals? It is sodium or okay, aluminium or tin, isn't it? And lead. These are amphoteric metals. Amphoteric metals. Okay. A metal M produces, do we have the answers? Yeah. Okay. We have zinc metal, we have aluminium metal. That means our option lies in these two. Our option lies in these two. Okay, a metal produces a gas N on reaction with alkalis like sodium hydroxide and potassium hydroxide. Let us take the option A and let us write the reaction. What happens when zinc reacts with sodium hydroxide? We know it forms what? What does it form? It will form okay, yes, sodium zincate, Na2ZnO2. This is called as sodium zincate. Okay, so here metal is taken as M and it liberates which gas? Hydrogen gas. So hydrogen gas is taken as N. Hydrogen gas is taken as N. Okay, fine. And the same gas that is N, okay, is produced when the metal reacts with dilute sulfuric acid. Okay, the same gas, yeah, of course, when the metal reacts with dilute sulfuric acid H2SO4, it will give what? ZnSO4 and it liberates hydrogen gas. Same gas is produced. Okay, when the same metal reacts with sulfuric acid, same gas is produced. That's correct. Okay, next, gas N reacts with another toxic gas. Gas N reacts with another toxic gas. Which is the toxic gas? Very simple. Carbon monoxide is a toxic gas, isn't it? Carbon monoxide is a toxic gas. Observe this. Gas N, which is that gas N? Gas N is hydrogen. Okay, gas N is hydrogen. Okay, M is zinc. So now this gas N reacts with a toxic gas carbon monoxide, okay, under very high temperature and high pressure, and it forms methanol. I have told you, okay, when carbon monoxide reacts with 2 moles of hydrogen, it will form methanol. Yes, we got it. Okay, what is it? So carbon monoxide is taken as P. Carbon monoxide is taken as P to form methanol at high pressure and high temperature and high pressure. Also, it reacts with metals like Q to form an electrovalent hydride here. Okay, yeah, it will form electrovalent hydride when this gas reacts with metals like sodium, okay, electropositive metal, it form metal hydride, isn't it? So this is going to be Q. This is going to be Q. Look here, M is zinc, M is zinc, N is hydrogen, N is hydrogen, okay. Yes, next P is carbon monoxide, P is carbon monoxide, Q is sodium, Q is sodium. Yes, what is the correct option then? Okay, A is the correct option. Understood? Clear? So it seems to be very big but very simple question. Understood? So we'll go with the next question. Yeah, okay. So guys, we have not learnt about hydrides. We will take up the next questions, okay, after a few minutes. Now we will talk about the next compound of hydrogen, which is called as hydrides. Yes, students, so as I said, now we will move on to the next compound of hydrogen. What is it? Hydrides. Okay, we will talk about hydrides. Yes. Okay, students. By the way, what are hydrides? What are hydrides? See, hydrogen, okay, hydrogen combines with almost all the elements. Okay, hydrogen combines with almost all the elements except, okay, yes, except noble gases. Okay, it does not combine with noble gases, and hydrogen does not combine with the elements of group 6, 7, 8, 9. Look at here, hydrogen does not combine with, it does not react with the elements of group 6, 7, 8 and 9, okay, except chromium. Except chromium. Chromium is in group 6, except chromium, okay, it does not combine with any other elements of group 6, 7, 8 and 9, and also hydrogen does not react with noble gases. So except these cases, hydrogen will react with almost all the elements. It will react with all the elements except noble gases and these groups, okay, yes, and these groups. Okay, yes, yes. So hydrogen does not react with noble gases and also these elements of group 6, 7, 8 and 9 except chromium. See, that means it will combine with almost all the elements. See, when, okay, now hydrogen, when hydrogen, okay, combines with, okay, yes, almost all the elements, it will form a compounds of the type, okay, MXHY. This is called as hydrides. Okay, they are called as what? Hydrides. Hydrides. Are you able to understand? Okay, when hydrogen combines with almost all the elements except those, it forms compounds of the type MXHY, which are called as hydrides. Now we are supposed to talk about hydrides in details. Okay, well, hydrides have been classified into 3 different types, guys. Okay, hydrogens have been classified into 3 different types. What are the different types of hydrides? Yes, okay, so hydrides will classify hydrides as first one, okay, first one, it is called as ionic or saline hydrides, ionic or saline hydrides. Next, covalent or molecular hydrides, covalent or molecular hydrides, and metallic or non-stoichiometric hydrides, metallic or non-stoichiometric hydrides. Okay, so hydrides, I told you, if, what are hydrides? If, okay, yeah, hydrogen combines with any metal, okay, it forms a compound of the type MXHY, which are called as hydrides, and these hydrides are classified into 3 types, which are those ionic or saline, covalent or molecular, metallic or non-stoichiometric. Okay, let us quote some examples for ionic or saline hydrides. Example, sodium hydride, calcium hydride, etc. Okay, covalent or molecular hydrides. Example, boron BH3, aluminium hydride AlH3. Methane is a covalent, okay, covalent or molecular hydride. Next, metallic or non-stoichiometric hydrides. Example, vanadium hydride VH0.5. They are non-stoichiometric. I will explain, okay, what are ionic or saline hydrides, covalent or molecular hydrides, metallic or non-stoichiometric hydrides, okay, in the next video. Okay, understood? So guys, with this I'll stop my video here. So in the next video we will talk about, okay, in detail about all these three different types of hydrides. Thank you.